Piecewise functions look a lot scarier than they are. First of all, I noticed on your test that this whole function notation thing is kind of throwing some of you for a loop. So this f of x thing is really just a label. It's the same as y equals. We could just as easily have y equals written right there. But instead we have f of x. F of x just means we're naming this function f. A piecewise function is two functions rolled into one. So the first part of it is 2x plus 3. If we're using x values that are smaller than 4, then we are going to use this piece of the function. If our x value is bigger than 4, then we're going to use the other piece of the function. So before you do anything, you need to think about what x value am I using, which piece of the function do I need in order to use that x value. For number 1, f of 5. F of 5 means we are going to use the f function. So we're going to use the one that's on the left. The other one is named h. So f of 5 means go to the f function. The 5 means that we are using an x value of 5. So take a look at these two stipulations. I'm going to label the top one blue and the bottom one green because this is Community Unity Week and today is Hex Day, so we are going to use Blue Spring South colors. So we will use the blue piece if our x value is smaller than -3. We will use the green piece if our x value is bigger than or equal to -3. Is 5 bigger than -3 or smaller than -3? Bigger. So we are going to use the green piece. We are going to use x minus 9. You're just plugging that 5 in. So 5 minus 9 is -4. Okay, I'm actually going to change number 2. Let's make number 2 say f of -10. Okay. F of -10. Is -10 smaller than -3 or bigger than -3? Smaller. So we are going to use the blue portion. We are going to use 5x minus 1. Plug that -10 in. 5 times -10 minus 1. 5 times -10 is -50. -50 minus 1 is -51. Number 3. F of -3. Is -3 smaller than -3 or bigger than -3? It's equal to, so notice that the green one has the greater than or equal to. We are going to use the green. Use x minus 9. -3 minus 9 is -12. Take a moment and try h on your own. It's the same. We have this time we'll do pink and purple. So the pink function is when we have x values smaller than or equal to 6, and the purple function is when x is larger than 6. Take a moment and try those 3 problems on your own. On number 4, 2 is smaller than 6, so we're using the pink function. Half of 2 is 1. 1 minus 10 is -9. On number 5, 6 is equal to 6, and the top function, half x minus 10, is less when x is less than or equal to 6. Half of 6 is 3. 3 minus 10 is -7. And then the last one, 10 is larger than 6, so you use the purple, the bottom function. -10 minus 1 is -11. When we graph piecewise functions, we are visually representing what we just did. So if we had a graph of the h function and we asked, what is the h function when x is 2? We could find 2 on the x-axis and then see where that line was on the graph. So we could evaluate by looking at the picture. This is a visual representation of the same thing. So the 2 functions, I'm going to use green this time for the top and pink for the bottom. These 2 functions are going to be put on the same graph. At what value do we switch from the green function to the pink function? Take a look at this part. at an x value of 2, that's where we're going to change over. If x is bigger than 2, we're going to use the top function. When x is 2, we'll use the pink function. And when x is smaller than 2, we will still use the pink function. So I am going to put in a vertical dashed line at 2 to let me know that that is the changeover point. That's where we're going to have to switch from one function to another.
Solid since of greater than less than equal sign.
Okay, let's start with the green function. 2/3 x plus 2. If we were going to graph that, we would start at 2. Slope of 2/3, that means up 2, right 3, up 2, right 3, and so on. And if you want to continue on the other side and put more dots, you could. Now here's the deal. We want to use the green function when our x values are bigger than 2. Think about the two sides of the graph, the left side of that orange line and the right side of that orange line. Which side has x values bigger than 2?
Right.
On the right side. So this function is going to be on the right side of that orange line. Why does it always do that during fifth? Now we're back. Once we figure out that this green function needs to exist on the right side, we also need to think about what's going to happen right at that orange line. Are we including 2 in the green function? X has to be bigger than 2. So I'm going to put an open circle. When we get to the orange line, we want to put an open circle. This is indicating that the green function is used to the right of that orange line, but not exactly on the orange line. And then we're going to treat this kind of like a rough draft. I'm going to erase the points on the left side because I don't want the green function on the left side. I want the green function on the right side. Okay, now for the pink. Since the green was on the right, that means the pink is on the left. And notice this symbol, less than or equal to. That means that the pink function gets to do a solid dot on that orange line. But let's ignore that for right now and just get this graph on here. Negative x plus 1. We start at 1. We have a slope of negative 1. And if I were you, I would extend it to the left, especially since we know that this one is on the left. We are allowed to have a solid dot on the orange line, and then this pink function needs to extend left of that orange barrier. And then, since this is kind of a rough draft, I'll go through and erase the pink points that I don't need. Okay, so now you could look along the x-axis and you could pick an x value of negative 5 and say, all right, if I was at negative 5, what is the value? The value is 6. If I have an x of negative 5, my y is going to equal 6 because I would use this pink equation. Negative 5 plus 1 is 6. Did I do something wrong? I think I'm just explaining it wrong. I'm flustered. Sorry if you're watching the video. My daughter's trapped at the pumpkin patch right now, and I'm kind of flustered. It's a funny situation. Ask me for the story. They'll actually tell me how many people actually watch my videos by how many people ask me how my daughter got stuck at a pumpkin patch. All right, number 6, let's start talking about it together, and then I want you to take the scary leap and try this on your own. It's not that scary. Mistakes are proof that you're trying. Mistakes help you learn and improve. It's important to try on your own and not just wait for me to shove it down your throat. So let's look first at the switchover point. According to this, our switchover point is at an x value of 4. So I'm going to put a dashed line at 4. Then let's think about left versus right. The green function, my top function, is when x is less than or equal to 4. Is less than 4 on the left side of this orange line or on the right side? Left side. So the green function is going to be on the left, and that includes the equal to symbol. So you're going to have a solid dot on the orange line. The pink one is then on the right, and it will have an open dot. Now take a moment, plot both of them, get the green one on the right, on the left side, and the pink one on the right side. So the green one is on the left, solid dot. The pink one is on the right, open dot. Do you remember the vertical line test? We talked about the vertical line test. The vertical lines can only touch one point at a time. If you put a vertical line straight down this orange line, we're only touching one of the functions. So this thing is still a function. That's why we've got a closed dot and an open dot, so that it preserves that vertical line test and makes it still a function. Step functions are basically a whole bunch of horizontal lines. This thing, f of x equals 1, 2, 3, or 4. That's like y equals 1, y equals 2, y equals 3, and y equals 4. So we're going to have 4 horizontal lines between specific intervals. So when x is between 0 and 3, we're going to be on that horizontal line at a y value of 1. Let's look for a minute at our symbols. Do you see how the symbol on the left has the equal to, and the symbol on the right does not? So the symbol on the left means that on the left side, we're going to have a closed dot, and on the right side, we're going to have an open dot. So horizontal line at 1, that'd be like here, but we don't want it across the whole graph. We only want it between the x values of 0 and 3. So 0, closed dot, 3, open dot, and I only want my horizontal line between those two. Next, we have a horizontal line at 2. So let's see, I did this first one in green. This next one I'll do in purple. Between 3 and 6. So I want a horizontal line at 2, but I don't want it across the whole page. I only want it between 3 and 6. Okay, so there's my second step. Next, I'll do pink. Pink is a horizontal line at 3, but I don't want the whole horizontal line. I just want one piece of the horizontal line between 6 and 9. So 6, 7, 8, 9. Erase the part I don't want. Eventually, you'll get good enough at this that you won't have to draw the whole thing and then erase. You'll just be able to go between those x values. And then the last one, I'm kind of running out of space. I need a horizontal line at 4 between 9, 10, 11, 12. Oops, I don't want a solid. I want an open dot. Do you see the nice little stair step? This is why it's a step function. And if you did the vertical line test, because of the solid dot, open dot on each vertical line, vertical lines are still only touching one point at a time. This whole thing is still a function. Okay, let's talk briefly about number 8, and then I want you to take the chance and try it on your own. Okay. First of all, look at our symbols here. Where are we going to have the open dot? On the left or on the right? Left. So this time it's open dot on the left, closed dot on the right. So it's kind of backwards of what we had in number 7. You're going to have horizontal lines at -1, -3, -5, and -7 between specific values of x. So give that one a try on your own. Here's my answer. Notice I have horizontal lines at -1, -3, -5, and -7 between specific x values. I had the question, what's the point of this? Let's say you're at the pumpkin patch and you're 5 years old or under, you get in a cheaper rate. So if you're under 5, it only costs $2. But if you're over 5, it costs $5. This is a visual representation of something like that. I got it in under the